So we're here at the example table, and in this video we're going to sketch the graph of f of x equals e to the negative x plus 2 minus 3. So let's start with something simpler, namely just plain e to the x. So the graph of e to the x is the nice familiar exponential function. It looks like this, and it passes through, so it has a horizontal asymptote along the x-axis, and it passes through the point 0, 1. Now it's worth noting, we're sketching this graph, so none of these other points really matter. We know the general shape, and the only other points that we usually care about are just intercepts. So we don't have to worry about what goes here, we don't have to plot some point over here, we're just sketching. So we have to transform now e to the x into this thing. And we have three things to do. We have to make x negative x. We have to add 2 to the exponent and subtract 3 from outside the function. So the first thing we'll do is add the negative to the x. And if you remember, if you have any function f of x, negative f of x, what does this do? This flips f of x about which axis? It takes positive values and makes them negative, negative values and makes them positive in the output, right? Because the negative is outside the f. So this flips f of x about the x-axis. If instead we have f of negative x, well, that's going to take positive values in the input and turn them into negative values in the input, and vice versa. Negative values in the input turns them into positive values in the input. So that's going to flip the graph about the y-axis. So f of negative x flips f of x about the y-axis. So good things to remember. In this case, we want to turn first e to the x into e to the negative x, so we're going to be using this one. All right, so e to the negative x, the graph of that then is this guy flipped about the y-axis. So it looks like this. And once again, we show the asymptotic behavior with respect to the x-axis, and we just label this point. This point didn't move, all right, because negative 0 is 0. So this is e to the negative x. Next step, let's add this plus 2. It's going to be a little bit trickier. Let's start on a new sheet of paper. So let's think about what adding 2 must do to the graph. Let's make a little table. E to the negative x and e to the negative x plus 2. So let's plug in a few values for x. Let's plug in 1, 2, and 3. So in the left-hand column, we're going to get e to the negative 1. Right? The x values I'll put in red. Then we get e to the negative 2 when we plug in x equals 2. And finally, e to the negative 3 when we plug in x equals 3. So how do we get the same exponents on the right-hand side? Well, if we want this to be negative 1, we need this whole quantity, the negative x, to be negative 3. So that means we have to make x equal to 3. So we have e to the negative 3 plus 2. Right? Negative 3 plus 2 gives us negative 1. What if we want it to be negative 2? Then we need e to the negative 4 plus 2. That gives us e to the negative 2. And if we want e to the negative 3, we need e to the negative 5 plus 2. So what does this tell us? If we want the function on the right to behave like the function on the left, we need to plug in 3 where we would normally plug in 1, 4 when we would plug in 2, and 5 when we would plug in 3. So that means that the entire graph is shifted to the right by 2. Right? 1 moves to 3, 2 moves to 4, 3 moves to 5. Now this might confuse you if you've memorized that rule that says if you add something in the function, right, if you have f of x plus 2, that's going to shift it this way to the left, right? So you may be confused here. The problem is we have a negative x, and so it's actually not really of this form. But that's why I like to do the table. Sometimes I forget the rule anyway, and even when I remember it, I might apply it wrong. So if I do the table, or at least the reasoning in the table, then I don't mess it up. So this shifts the graph to the right by 2. So the graph becomes e to the negative x plus 2. This graph will look like this. It looks exactly the same, right? So here, the only thing that we change are the labels. So we don't even have to, we usually don't have to label this point, but it's worth thinking of. We've shifted to the right by 2, so the point that was 0, 1 is now 2, 1. And let's just make a note of our new y-intercept. If we plug in x equals 0, e to the negative 0 plus 2 is e squared. So this point is 0, comma, e squared. Same asymptote, though. The asymptote is still the x-axis. The last thing to do is to graph e to the negative x plus 2 minus 3. So when you subtract 3 from the output of this function, or when you add or subtract any constant, that just shifts the graph up or down. So if we're subtracting 3, that's going to shift the graph down by 3. So we get something that looks like this. Now let's draw the asymptote. Before we didn't need to draw the asymptote explicitly because it was just the x-axis. Now if we're shifting down by 3, the horizontal asymptote also shifts down by 3. So this is the line, y equals negative 3. And now we shift this curve down, and it's going to look something like this. So how do we know where these points are? In particular, why do I know that that point is above the x-axis? We're only sketching this, so we don't have to worry about scale, but we do want to get things like that correct. Well, what is this point? This point is what you get when you plug in 0 here. And when you plug in 0 here, you get 0, comma, well, e to the negative 0 plus 2, so that's just e squared minus 3. E squared minus 3, right? It's just this point shifted down by 3. E squared is bigger than 3. E itself is bigger than 2, so e squared is bigger than 4. So this quantity here is definitely positive. So we know that this point is above the x-axis. And so for a sketch, that's all we need to know. Only remaining thing to find is this point. This is the point at which the function value is 0. Right? If e to the negative x plus 2 minus 3 is 0. So let's just do a little bit of quick work. If we want to set this equal to 0, that means that e to the negative x plus 2 equals 3. Take the natural log of both sides to get this exponent out of the exponent, and we get negative x plus 2 equals the natural log of 3. And then if we solve for x, we get x equals 2 minus the natural log of 3. So this guy here, we already have the y-intercept. The x-intercept is what we just found. This is 2 minus the natural log of 3, comma 0. And there's our graph.